Okay, so you've definitely seen them. They're all over our social media feeds, right? These humanoid robots doing just incredible things. But what's really going on behind the curtain of those viral videos? Let's talk about it.
Yeah, you know exactly the ones I'm talking about. That Boston Dynamics Atlas robot doing parkour, just effortlessly leaping over obstacles. Or those other robots pulling off perfect backflips. It's just mind-blowing. Honestly, it looks like something straight out of a Hollywood sci-fi blockbuster. And it's not just the visuals. The promises, they're somehow even bigger. You've got Elon Musk out there saying Tesla's Optimus robot isn't just a big deal. It's going to be the biggest product of all time. He even suggested it could, get this, end poverty. I mean, the hype is just off the charts.
So this is what we're going to call the robot spectacle. And look, it's really easy to get swept up in it. That's the whole point, right? It's designed to grab our imagination and, let's be real, grab investor dollars too.
Which brings us to the big, crucial question here. How much of what we're seeing is actually real, and how much of it is, well, just a really good show?
All right, to figure that out, we need to pull back the curtain. Let's get a serious dose of reality, and we're going to do that by listening to what the actual experts in the field have to say.
So let's look at the World Economic Forum in Davos. A whole panel of top robotics experts got together, and they all pretty much landed on the same page. The big challenge right now? It's not about making another robot that can do a cool backflip. The real hurdle, the next major frontier, is getting these things to actually work reliably and affordably out here in the real world.
And this is where it gets really interesting. One of those experts, Jake Lucerian, the CEO of Gecko Robotics, he dropped a bit of a bombshell. He called teleoperation the industry's dirty little secret. So what does that mean? It means in a lot of those slick viral videos, there's a person, a skilled human operator, sitting off camera with a controller, puppeteering the robot's every move.
This just perfectly highlights the gap between what we think we're seeing and what's actually happening. You see a robot that looks totally autonomous, but in reality, someone's often pulling the strings. You see a robot perfectly fold a single, pre-placed towel in a lap. But in the real world, that same robot would probably just stare blankly at a messy pile of laundry in your bedroom. The unpredictability completely throws it off.
So this huge gap, this canyon between the controlled lab environment and the chaos of the real world, that's what we're calling the deployment chasm. And make no mistake, it is the single biggest obstacle the entire industry is up against right now.
Okay, so what causes this chasm? Well, it really boils down to three major bottlenecks. These are the things stopping these amazing prototypes from becoming practical, everyday tools. Let's break them down. There's a big data problem, a technology gap, and a pretty staggering cost barrier.
All right, first up, data. You'd think, hey, just feed it the whole internet. But nope, it's not that simple. An AI for a robot needs data from its specific environment. Think about it. Every factory floor, every power plant, every warehouse is unique. The lighting is different, the layout is different, the objects are different. That kind of super specific, real-world data, you just can't find it online in some generic data set.
Okay, number two is the tech gap. Even if you had all the right data, today's robots really struggle with what's called fine-grained perception and manipulation. Fancy term, but it just means seeing and handling things with human-like dexterity. They don't have our common sense. They can't easily figure out an object they've never seen before, and they get totally confused by things that change shape, like a t-shirt.
And that brings us to the third bottleneck, cost. And wow, get this, MIT's Daniela Rust did the math. To develop and deploy a robot that could reliably fold laundry in any home at scale could cost $500 million, $500 million. That one number just says it all, doesn't it? It shows you just how far away we are from having these things as affordable helpers in our homes.
Okay, so the challenges are obviously huge. But the experts aren't just sitting around pointing out all the problems. They're actively working on solutions. So let's switch gears and talk about how we can actually start to bridge this deployment chasm. One of the key strategies on the table comes from Jake Lucerian again. He calls it forward deployment. The idea is pretty simple but powerful. Instead of trying to perfect a robot in a sterile lab for years, you get it out into the real world, its actual target environment, as early as you can. Why? To start collecting that high-quality, super-specific data it needs to actually learn and get better. It's about learning on the job, basically, not in a classroom. And what's cool is how this idea fits into a bigger roadmap from all the experts. You've got Lucerian tackling the data problem with this forward deployment idea.
Then you have Daniela Rus from MIT attacking the tech and cost problems by pushing for better, cheaper sensors and banking on economies of scale as production ramps up. And finally, you've got Xiaotan Len, who's focused on a different piece of the puzzle. How do we make these things easier to teach in the first place?
Xiaotan Len's approach is just so pragmatic, so sensible. He's basically saying, hey, let's not try to boil the ocean here. We don't need a robot with human-level intelligence right out of the gate. We can get a real return on our investment right now by putting simpler robots in structured places, like factories and warehouses. Have them learn by watching humans do simple, repetitive tasks. That's the beachhead. That's how this tech gets a foothold and starts to pay for itself, funding the next wave of innovation.
So, when you put all this together, what does it actually mean for the future? Let's zoom out and look at what the path forward probably looks like for the next decade or so.
Okay, so today, right now, we are squarely in the age of hype and super controlled demos. But in the next few years, you should absolutely expect to see real deployment happen in those structured environments we talked about, factories, warehouses. Then, looking out maybe a decade, we'll start to see them move into more complex, less predictable places. The key takeaway here is that this is an incremental journey. It's not going to be an overnight robot revolution.
And as we go down this road, we have to remember the conversation can't just be about the tech. It's got to be bigger than that. We need to be talking about transparency from the companies building these things. We need to talk about the very real impact on jobs. There are huge ethical questions around safety and who's liable when something goes wrong. And maybe most importantly, how do we make sure the massive benefits from all this are shared fairly across society?
Look, at the end of the day, the consensus from the experts is crystal clear. This stuff isn't science fiction anymore. It's coming. The progress is absolutely real, even if it's a bit slower and more deliberate than the flashy videos wanting you to believe. And that leaves us with the one, final, and most important question of all. The technology is coming, but are we ready for it?